Tristan, welcome to Validated.
Hey Austin, thanks for having me back on the podcast. Good to be back here.
Yeah, glad to have you back. Last time we had you on, I think this was the very beginning of what was then Zeta's next iteration move, and we were talking a little bit about like high performance DeFi, where kind of the future is heading. I think you guys hadn't fully unveiled the plan for what's now Bullet at that time. We kind of teased some of the ideas that you were talking about. So I want to talk about a whole bunch of things today. The first is like CLOBs are back. CLOBs were like all the rage in 2021. That was the original vision for Serum, which was honestly the main thing that I think brought a lot of people to Solana in the early days.
Yeah, including myself.
Right, then CLOBs kind of went away for a while, and then now they're back, both on-chain, sort of on-chain and off-chain. So I want to dive into a little bit of the history of CLOBs and, you know, what brought you guys to kind of the position you guys are in today, where Bullet is not a standard application on Solana. It's also not exactly an L2 on Solana. It's kind of in this like slightly different space, I would say. Kind of curious to hear how you would describe it. But let's kind of start out with the CLOB wars before we get into where Bullet is today and kind of the evolution from Zeta. So walk me through a little bit of, in your mind, the history of CLOBs on Solana and sort of where we go from there.
Yeah, I think you summarized it quite well, that CLOBs have been around for a very long time, obviously in traditional markets, like literally decades. That's been the gold standard. It really dominates centralized crypto finance as well. Pretty much every notable major centralized exchange uses order books. It was also something that was, I think, one of the first candidates in DeFi, I guess, with dexes like Kyber, Ether Delta, some of these other ones, I think, using these way back in the day. But those had some pretty clear issues built in a DeFi setting. That's kind of when we got into DeFi, I would say, when I started looking at it properly. I kind of came back into crypto and just kind of observing what had happened over DeFi summer after I'd taken a bit of a hiatus. And I saw, you know, how much innovation was happening in DeFi. It was all around yield farming, and people were building, you know, AMMs and things around Uniswap. And there was definitely this kind of first wave of kind of order book type products, but they didn't scale very well. A lot of reasons around that. Obviously, just the gas and compute constraints that you have in these on-chain environments is very limiting. If you're, for example, building on Ethereum where you have, you know, single digit or low double digit TPS, you have high gas fees, you know, needed to do a lot of order book computations. Things are kind of slow. You ended up having these order book experiences. Like we were building, you know, options way back in the day, and we saw some people building these order book options protocols on Ethereum, and they had like 5% spreads. They had like one trade happening every couple of minutes. To place a trade, it would cost you anywhere from like $20 to $50 or something or other, just because the gas cost was so high to do all the matching. It was just like completely infeasible. I just looked at that and I was like, it's a cool proof of concept, but like no one in their right mind is going to be trading on this thing. Like there's just zero chance. And that was actually
so
when
how
I
much
came.
of that? I'm just curious, how much of that felt like it was structural to you versus like an implementation issue?
That's a good question. I mean, I think structurally people know how order books work. Like they've kind of been done to death. There's a million like implementations out there. I think it was more just kind of the smart contract programming languages, and you're kind of building almost in this like embedded systems environment. You have to gas golf everything. You have to be really smart about it. I mean, that's when we started building the option stuff. We had to do an order book on chain. We had to do Black-Scholes on chain, all these like big calculations essentially that were pretty chunky. And even Solana, to be honest, at the time, it was a real struggle, you know, and you're talking about 10 times probably the throughput or more that Ethereum has. And even then we were hitting this like 200K CU limit that was like back in the day. Any kind of math that you wanted to do, there was no like really good library for that. You had to use what's called like fixed point arithmetic essentially to do all these floating point calculations. Very complicated when you're doing Black-Scholes, which is, you know, all these different like partial differential equations and, you know, logarithms and exponents and stuff like that. That actually is like, I don't know. I kind of started reading into all these manuals on how people build calculators, and I have a newfound appreciation for the guys who build that. You know, you buy a calculator for like $10 and you use it in school and you're like, okay, whatever it is, what it is. And then you look at like how they implement these things on a computer, the different algorithms that go under the hood. For example, if you're trying to do something to a power or to a logarithm, essentially people have to do these approximations under the hood, these kind of Newton methods, iterative methods, and you kind of need to keep the cycles and the compute limits fairly bounded. And so it was actually quite similar porting that to Solana. I was looking at some of the tricks that people were doing for approximations, and you can get to very high precision, but you can take down the compute very, very significantly. But yeah, you're building in this very constrained environment, and that was always like a real challenge, I think, to do. And that's why AMMs are really nice. Extremely simple math, X, Y, K. The other great thing, probably arguably more important than just the math itself, was just the ability to provide liquidity on these things. Made it really simple. You, retail person, come there, you put token A, token B in a two-sided pool, and suddenly the market is created and anyone can trade back and forth. The problem is, I think, market making is not straightforward, I think, on an order book. You definitely have to have some sophistication. That's why Jump and Wintermute and all these guys exist and have a good business model, especially in traditional markets as well. And I think for like early retail people getting into crypto, like you would have to spend a lot of time writing bots and understanding how to hedge out your positions and do all this kind of stuff. And so it was funny, like my co-founder actually cut his teeth on DeFi back on Kaiba, which was like the first DEX on Ethereum. And it was a really weird model. You look now, like all these projects going out, they're like, we need market makers. We're going to pay them a bunch of money to come and market make and provide liquidity. The model was actually completely flipped on its head back in the day. To come and have the right to market make on an exchange, you would have to pay money to the exchange as the market maker. And so they would have to pay money for the privilege of going and market making. Yeah, I wish it was like that. That was great. But that's kind of how it was. And these guys would come and they would try and market make. But yeah, I think there was just very few candidates of people who could do that. Hard to get liquidity, and then hard to actually kind of implement such a model. Like if you look at some of these traditional order books, they can do hundreds of thousands, if not millions of transactions per second. You're walking the order book. You're having to do all this kind of matching engine logic. And this works really well in a centralized environment where you just have a server that just has like infinite compute constraints, more or less. But yeah, when you're doing that on chain, that limitation just really narrows down the design space, and those kind of became infeasible. But things have changed a lot in the last couple of years since 2021. And I feel like we're coming back with a bang. Like obviously compute limits have increased on Solana, which is really nice. So not only have people started to do more funky stuff there, but I think generally, especially with what we're doing in this kind of network extension model where ZK has now become a big thing, you can do this essentially verifiable off-chain compute essentially. And that really means that you don't have to synchronously run your code, I guess, with the rest of the network. You can kind of branch off, do a ton of work, and then you can essentially attach a proof that this computation was valid, post that back on chain. And I think that's a nice, like, interesting model and a complement to what's being done on the L1 at the moment.
So you guys made, I would say, a pretty big decision for the future of Zeta, which was to move from a model of building a standard, typical on-chain application to building something that kind of falls more into the Solana network extensions framework. I think if you're coming from an Ethereum world, you might call it an L2, although like it's not exactly an L2. I'm kind of curious how you would describe what Bullet is, and then we'll go into sort of how it's different from Serum or a CLOB that was just built directly on Solana that came before.
Yeah, sounds good. So I can give a bit of the context with Zeta, what we were building. We've been on Solana for a very long time, since really the early days. We came through a hackathon, so that's kind of where we were born and bred, I guess. And so the crux of our exchange with Zeta was very much an extension of Serum back in the day. We saw Serum, like we talked about, and I found it very compelling and interesting. This is the first time that someone's been able to put a order book fully on chain in a smart contract, which was something that Solana uniquely enabled, and I thought was really cool. And that worked pretty well. We did $15 billion of volume. We got quite a lot of people trading on it, and we kind of extended Serum for derivatives trading, first options, and then we did a bunch of perp stuff. So I think that was really nice. We definitely, I think through the bear market, we didn't have that traction that it really like showed us where the chinks in the armor might be. And so we spent a lot of time optimizing and refactoring. Thank God we did, because when Solana really started popping off, I guess, over a year ago, we started getting a ton of traction. And that was really nice, because without that tinkering, we wouldn't have scaled, I think, to the levels that we did. But having hit those levels of, 100K plus users really puts a lot of load on your system, as it did for the layer one as well. I think definitely exposed a lot of things. There was all kinds of transaction sending problems, and those were all kind of addressed in due time, which is really nice. But I think for us, outside of the pure technical stuff as well, it just kind of exposed a lot of interesting stuff on market microstructure, profitability of market making, the ability to provide really deep liquidity on chain. And so my goal has always been, how do we compete with centralized exchanges and provide something that isn't like a strict compromise? We want the best of both worlds, where you get transparency, you get verifiability, but you don't compromise on UX and speed. And I think looking at examples like Hyperliquid, it's pretty clear that people care a lot about usability. Like, that is the primary focus for users. They want to come in there, they want to have really good trade execution. They don't want to pay 50 basis points on every trade, essentially, for the right of being on a super decentralized network. And I think that's very reasonable and like a logical decision that people would make. So I guess some of the challenges that we ran up against, there were a few. So one is just really latency, is I guess what I call it. With Solana, you have 400 millisecond block times. Those are largely fixed. There are efforts with Anza underway to essentially bring that down. I think they're bringing that down into the realm of about 100 milliseconds, which is really exciting to see with Alpenglow and some of the other consensus changes. I think really, really cool stuff that they unveiled at Accelerate this year. But when you look at traditional markets, a lot of the price discovery, and for example, on Binance, a lot of the trade timings there are happening on the order of 5 to 10 milliseconds. So things are happening very, very quickly. If you look at traditional markets, actually stuff is happening on nanosecond or microsecond level if you've read into the HFT. So, they're using FPGAs and custom hardware. We're not quite there on the crypto side, and hopefully we don't get there as well, because I think there are very incremental gains and you're just kind of trading at these very high frequencies. I don't know how much that really benefits society, to be honest. But yeah, price discovery happening, I think, at the pace that centralized exchanges happen is quite important. Otherwise, you just get a lot of centralized exchange, decentralized exchange arb. And I think over time, Solana has really proven that there's going to be a lot of new asset issuance on chain, as you've seen with Pump Fund token, as you've seen with the various multitude of launches that's happened on Solana that have popped up on Jupiter and Radium and some of these platforms first before they've gone on centralized exchanges. And I think that will continue to happen. That's where the opportunity is. That's where people are starting to want to deploy their tokens. That's where you're getting distribution straight away.
Yeah, I feel like there was this kind of crazy moment with the Pump.Fund launch where it feels like for the first time, probably in 5 years, there was a major launch of a token where price discovery happened in real time on chain as opposed to off chain. And of course, it then shifted very quickly back onto off chain. But it was sort of this interesting moment where at least what I saw was the SEX trading was not ahead of the on chain trading. Now I'm hardly an expert here in that, but it was pretty interesting to see. I kind of you brought up a few interesting topics, I think, that are worth going into. The first is, I think Hyperliquid's kind of like the darling of the CLOB watchers at the moment. And one of the interesting things about it is it controls what you're allowed to do far more than a traditional on-chain program would. There's little things like cancel prioritization, right? Which is the way a traditional market works for the most part, but it's a pretty big departure from the way on-chain order books and those types of systems have historically run. There's sort of been this idea of well, the code is up here, and however you interact with the code is legitimate past some exploitation of a smart contract bug. But if someone wants to, sandwich you or front run you, or, they want to pay more money to get ahead of your cancel, that's their God-given right as an on-chain trader. How do you guys think about, for lack of a better term, the social contract between Bullet and both the maker side and the taker side?
Yeah, that's a really good question. So I think to kind of backtrack and talk about some of the models that people have approached CLOBs with. So I would say, yeah, the first attempt was really, let's do the fully on-chain order book. This was all the rage in 2021, as you know. And like I mentioned, there are some drawbacks to that. I think the fact that every order you place has to pay gas costs, essentially. And you have to compete with all the other blocks based on Solana. Even though it was pretty low on Solana for the longest time, once things started popping off, it becomes pretty prohibitive, I would say, for people to start trading on this thing, especially if you're a market maker and you're literally placing millions of orders. You're paying, especially priority fees. Like the base fee is largely okay, but you're starting to compete with what's happening on meme coin launch pads and NFT platforms. And these guys are starting to pay thousands of dollars a day, potentially during like network traffic to kind of keep on top of the market, which actually eats into your P&L and becomes really hard. There's this big adverse selection problem, like we kind of alluded to briefly, which is that market makers that have resting liquidity on there's a lot of toxic taker arbitrage bots that will come in there and continuously kind of snipe your orders and try and profit off them as much as possible. So there is somewhat of a cost to market making and to liquidity that has to be subsidized by protocols, for example, and that can kind of be pretty expensive, I would say, and doesn't scale as well as you would like, and kind of erodes the profitability there. And so that's why things have kind of converged, I think, on AMM type models, RFQ type models. That's what we're seeing for typically a lot of the perp stuff. Even on the spot side, I think there are some routers that are also integrating, Pith Express Relay and doing stuff like that. So that's how things have shaken out a little bit.
Yeah, when you have a controlled environment like you guys have, like, how do you think about that differently than when you were building Zeta?
I think it's a means of progressive decentralization, essentially. I think that's the way to approach these things. I would say, in retrospect, it was somewhat of maybe not a mistake, but like taking too many steps forward in terms of the fully decentralized model, because you make it very hard for yourself in terms of achieving the performance and the kind of market microstructure that you really want. You kind of leave it up to the world, and there's not a lot of opinionated choices that you can make, essentially.
Yeah.
Whereas I think the nice thing with Hyperliquid essentially, so yeah, like I said, there was the fully on-chain approach. There's the off-chain order book, on-chain settlement approach that some people took. I think that has its own problem. That's like very trusted, right?
Yeah, seems, isn't that just a brokerage by another name?
Yeah, I guess so.
Like
that's how
I'm not sure what the difference between that and Wintermute is at that point.
Yeah, I think there's definitely some risks there in terms of censorship resistance, and there is a lot of trust placed in the team to do the correct thing. That's kind of how DYDX v3 worked. Everything was matched on a centralized AWS server, and funnily enough, when AWS went down, I think in one of their regions actually brought down their whole exchange, which kind of begs the point of like, why even build on a blockchain in the first place if that's essentially going to happen. And then Hyperliquid took the approach, and same with like Fogo and some of the others, of let's just fork an existing network, or let's just take, I think Hyperliquid's based on like Comet BFT. Let's just take some kind of existing stuff, run it in a permission kind of validator set of 4, or maybe it's like 10 validators right now. They all sit in the same data center, talk to each other. Yes, we lose geographic decentralization, but all the nodes are, supposedly being run by different people. I think the foundation does run probably the majority or quite a number of them. But that's kind of one step towards building out this kind of more decentralized model. The nice thing is we have extremely good performance. Now we're hitting, 100K peak TPS, and we have all the kind of ingredients that we need for a really good exchange. And I think to their credit, it's worked pretty well for them. Their exchange has a lot of traction now, where they can start to go and solve these problems, bring more people on as external contributors. I like how Jeff has kind of done it. He's basically said that we have a very small team, and Hyperliquid is not just the 10 of us. It's actually hundreds of people who are building in there who are contributing, which I think is really nice. And it kind of, I mean, they're not open source, but it's trying to like be a bit more in that model of, you have a lot of contributors coming in, the kind of contribution model becomes a lot more decentralized, and
you can actually run an archival node now.
Yeah, exactly. And so that's that model, which is the kind of permissioned co-located L1. And then we took a bit of a different approach. We were thinking about doing something that like Fogo did, but then we kind of went off it just because I think there's like more overhead running an L1. You have to coordinate all these different nodes, and then it feels, I think, somewhat competitive to the existing L1 that you're just forking a bunch of stuff. And we'd seen some pretty interesting stuff happening on Ethereum's roll-up roadmap. It definitely has had some of its own issues, but I think some of the technology is quite compelling, and some of the breakthroughs in ZK are also quite nice. And I'm also just a big fan of the roll-up model in general for order books, because I think order books need this kind of centralized place where order matching happens, this kind of central piece of state that everyone can talk to. I think it's very hard when you have this distributed order book. You have the shards, essentially, like some of the exchanges on Solana, like I know Drift use this kind of decentralized limit order book. Everyone holds like basically a shard of the order book. You have to recombine it essentially, and then you have to figure out from there. We don't have to deal with that so much. And you might argue like, oh, this feels very centralized sequencer, you know, we hate this, etc., etc. But I think that's where the ZK stuff comes in. And some people have been terming it more like a verifiable server almost. You can basically talk to this. It's like, it feels and gives the experience of a centralized exchange, which means very low latency. If you're co-located, very fast order matching, you get what I would call execution guarantees. So when you send a message to the server, it basically pre-executes it, gives you kind of a simulation of that. And you kind of know with very, very high confidence that this is the state that you're going to get. So this is very important for trading, right? I know if my order filled or didn't fill, and I can make business decisions based on that. You know, maybe I go and hedge if I get my position filled. The problem, I think, with Toli's model, in my opinion, of doing this fully decentralized thing is you only get inclusion guarantees. So you would send it to your leader and you say, hey, I want to trade this order. And then it will come back to you and it's like, this thing will go through in the next couple of seconds. Or, you know, we know in 1 second that you'll go through, but we can't tell you what's essentially going to happen. And the trade is just like, well, that's great that I'm going to get sequenced, but I don't know if I got filled or not. And I'm going to hear back in like a second, essentially. And then I make my decision. So it's this kind of lag, essentially, like, that I think,
I guess sort of to play devil's advocate on that, like, isn't that the way that TradFi kind of works today, where you actually, like, you get filled, but you can get rolled back, and people do get rolled back all the time. Mm-hmm. And going from T+2 to T+1 settlement was like a big deal. But like, I'm kind of curious where you guys see like, there's this kind of like interesting thing where there's sort of this debate around, does inclusion matter more or does finality matter more? And I don't think you're someone who says inclusion doesn't matter, but it's always been confusing to me, the people that are like, oh, inclusion can be whenever, like finality is the thing that you really focus on. And so I'm curious where you guys see opportunity to not just prioritize inclusion, which is kind of what TradFi does. And as you mentioned, a little bit of the MCL route that Solana's working on, to a point where knowing if you're filled or not becomes like a meaningful competitive advantage compared to other types of trading venues. What do you guys kind of see there that is behind that thesis?
Yeah, I'll see if I can crystallize my thoughts. I think personally it's quite important, having traded a bunch myself and talked to very big trading firms. That's something that's really nice on centralized exchanges, is you do get these acknowledgements back very quickly. You can adjust your logic. Everything is happening in real time, essentially. Rollbacks do happen, obviously, but that is like a very unfortunate thing that people hate, and, you know, tends to lose trust with exchanges. Like, we've seen situations in the past where, you know, when people have a lot of trades rolled back, obviously, that's when a lot of support tickets come in. People dispute essentially where they got filled, where they missed out on trades, stuff like that. I think it can get very messy. Yep. So the more that you can increase that reliability, I think is quite important. I think with Solana, essentially always having that baked into everything, where you have to wait, give it a couple of 100 milliseconds, there's rollbacks, and things like that. I think it's definitely an improvement on the current model. I think it's going to still encourage a different breed of trader, essentially. So I think these jump type guys are still going to find it very hard to trade on these kind of systems, because you're firing a bunch of orders into the void, and you're kind of saying like, yeah, these will get sequenced, but you don't know exactly the prices that you're getting filled at, or maybe you have to use all kinds of special order types to make sure you get landed on time. That was actually a big thing on Solana. People would send orders and you kind of didn't have good, strong guarantees on whether you were going to get
Yeah.
executed. And so you would have what's essentially time enforced orders, which are these auto kind of time to lives. And you're like, yeah, if my thing takes a few blocks to essentially go in, or I'm not actually able to send a cancel to take that back off, this thing will auto expire itself. So you have to have all these like kill switches built in. And that's just typically not something that's really strictly necessary, I think, in centralized exchange models. So for us, we're not trying to reinvent the wheel. I think we're trying to mirror as much as possible on these kind of well-established venues where this kind of stuff is working. Because then we can just go to these big traders and say, hey, we have a platform, gives you similar guarantees, you have similar APIs, we want to bring this, price discovery on chain and have you trade all these, native assets. And I think there is a lot of market demand for that. People want to be trading in these kind of environments.
Yeah.
And I think the performance guarantees and the way that it all works, I think feels a lot more like these models, in my opinion.
So what's your pitch to someone who is a professional trader, right? They're currently co-locating with Binance. Why would they ditch the centralized trading venue with all of the, creature comforts that it provides? And yes, it doesn't provide quite as much security, but Binance is pretty lindy at this point. Coinbase is pretty lindy at this point. I think it's fairly unlikely that those are gonna explode, although, who knows. And say to them like, hey, Bullet can actually provide you with something that is like different. Like what is that difference that makes people want to trade on it?
Yeah, it's a good question. I think on the technical side, definitely we're just trying to reach parity in terms of like performance there, essentially. I think that's table stakes, essentially. And that's a big reason why people don't trade on DEXs or have such a hard time, is because suddenly you're having to talk to all these different RPCs. I've just heard so many nightmare stories of like, oh, I have to deal with Solana's like Geyser protocol and like all these packets are getting dropped and I have to build so much custom infrastructure just to do indexing and all these kind of things, like quite a lot of work. So for us, if we can provide a similar experience, which means that we're giving order acknowledgements within a couple of milliseconds, which is, basically enabled through our pre-confirmation model. We give APIs. I'm kind of building a fairly Binance compliant API spec. So take your trading stack and with a few minor modifications, you can get started and trading on our model. It's not like with our old DEX, someone has to, we have a C++ stack. We're going to have to now build JavaScript trading framework, which is not at all optimized for trading. It's slow. You have to rewrite all your kind of calls to be this JSON RPC spec. You have to deal with rollbacks or things on different kind of processed or confirmed levels. So people will have to write a lot of logic to retry things. You have to do all this fee estimation. It's like quite a headache for these guys who are not born in the Solana trenches to figure out. So that's one, just like get integrated. We can do it in like 2 weeks, hopefully. And it's not too much pain. That's like a big cost to like market makers don't want to touch new exchanges because they have to sink weeks or months of engineer hours into this thing to even justify, these guys are trying to make money, right? They want to trade on there. And if they're going to have to dedicate 2 months of engineering resources to integrate this thing and it's a flop, like that's a big loss to them. But I think the more important sell is these guys, to make money and to run their business, fundamentally, they make markets, right? They post bids and asks, and people need to trade into those bids and asks, and they profit from the spread. And that's kind of a volume game. Like the more that people trade into you, the more tighter you can quote, essentially, and you just kind of, that's what sustains your business model. And so they need retail flow. If it's HFT1 trading against HFT2 and they're all just trying to snipe each other, no one makes money, and it's just like a really bad situation for all of them. And that's unfortunately how a bunch of DEXs have kind of turned out. I think when the incentives dry up, there's no retail flow, there's no retail interest. These guys can't make money, it's not profitable, and as a result, they kind of are not willing to quote super tight. So it's just kind of like a lose-lose. The opposite model, which is kind of why Hyperliquid, I think, really achieved like breakout velocity, was because they engineered things really well towards market makers in the early days. They added this like speed bump or like cancel prioritization, meaning that they were offered a bit of protection essentially to come in and provide really liquid markets. Retail sees that and they're like, hey, this is great. We get really good liquidity on a bunch of different pairs. Obviously, there's some kind of reward scheme, point system that kind of gamifies it and gets people interested. these guys start trading a lot of volume. Hyperliquid's now doing $5 or $10 billion of volume. I can imagine it's probably pretty profitable for the market makers to be trading on Hyperliquid, because you have all these retail people trading the pump fund pre-markets and like early, trading of the token. Spreads are quite wide. The market makers are willing to come in there and, trade or quote attractive spreads. And if people are trading into them, they kind of have a fair value on what the token is worth. And so they actually kind of make money off that, which is really nice. And so for us, I think our pitch to them, especially, is we're trying to engineer that towards Solana. Can we build a really good, professional grade perps exchange for Solana? We should have access essentially to the millions of users that use Solana. I think there is a lot of pent up demand. Like, I talked to a bunch of people in Telegram and Twitter who are all like, I want to trade more perps, but I have to bridge cross train, use other protocols to do this. Some people do it. Some people just like ignore it altogether and just stay on chain on Solana. And so I think, there's just like a lot of demand out there. I think this was also validated through the Phantom perp stuff. It was interesting that they picked up an integration with Hyperliquid, and now people essentially using Phantom, which is kind of like the Solana native wallet, can trade essentially through their mobile app. And they've already done at least a couple of 100 million volume, and using builder codes and stuff like that. I think it's definitely like a telltale sign that I think there is some demand for this and people want to start trading that. And so, I think when you talk to these market makers and they're like, hey, you're on Solana, they're like, wow, that's like a really good part of the go-to-market that I think is like underrated. If you're a Cosmos app chain, or you were building in some ecosystem that had not that much traction and was really hard to bridge into, I think you'd be speaking a completely different story. But I think people are very excited because I think there's a big audience to tap into.
Yeah. So if you think about the characteristics of Bullet compared to like the Zeta deployment on Solana, like what does that look like in terms of how quickly the market actually moves? Let's get a little bit into some numbers of what that experience is like from like an actual A and B perspective.
Yeah, absolutely. So concretely, the numbers that we're seeing on Testnet right now is we're getting about 3 to 3.5 milliseconds of what we call like P50 or like median latency. That means that basically the 50th percentile of orders that go through will get executed. And that's like, I'm measuring essentially from the ingress of like it coming in on the HTTP port, getting executed on the sequencer, and then being basically sent out. So we're removing essentially that network latency of people sending transactions. So you can imagine we're measuring it as someone who's basically sitting in the next server rack to the sequencer and just like talking there, because I think that kind of keeps things easier to measure. So 3.5 milliseconds is very fast. That's actually, I believe, faster than Binance, which I think is very cool. And I think we can continue getting it down. I do think there are pretty marginal improvements below 10 milliseconds.
Binance order book moves at more than 3 seconds?
I think so. I people quote different numbers essentially. I heard from some trading firms that Binance trade to tick time is about 5, or maybe it was something like 3 to 5 milliseconds. So yeah. That's slower than I would have thought. Interesting. Yeah. I mean, look at FTX. They used to run their whole matching engine, at least in the early days for the first couple of years, was all written in Python and incredibly slow. And then there was a whole effort to like redo it. But, I think there is some legacy. I don't know how Binance's one is written, but ours at least is written fully in Rust. So I think we're getting pretty top tier performance on that.
Yeah, this is the famous like FTX never goes down. It just queues orders for 20 minutes.
That's right. But yeah, I think like there is marginal incremental improvements once you get below 10 milliseconds. So we're just trying to be on par. I think getting down to like sub 1 millisecond, I don't think matters too much because it's just all HFT trading back and forth. I think for at least users, that's really nice that when you click something, and that's actually my kind of light bulb moment with Bullet, is when I trade on our testnet, I click the button and the confirmation for my trade being filled is instant. It's like Web 2, like me clicking and loading a web page or some kind of interaction in a React app. It basically feels instantaneous, which is really nice. So 3.5 milliseconds there. The other thing I think is really nice is our jitter, or our kind of worst case, is also quite good. That's a very important thing for trading. You might say, hey, I'm getting down to 1 millisecond for, 50% of my trades, but 1 in 100 trades gets executed in, 500 milliseconds. And that's actually like a really bad thing for traders, because that one trade they're going to lose a lot of money on, because it's just going to basically get traded against, or is going to be very slow into the market. So we've been measuring our like P90, our P95, all these kind of metrics on what is roughly our worst case. And that, I think, if I remember off the top of my head, like our P95 is still below 10 milliseconds, which is really nice. So we're trying to keep essentially a ceiling on worst case, transaction performance, because that means that, people don't just randomly lose money on like one out of every couple of hundred trades. What else? In terms of like TPS, that's less of a concern for us, I would say. That was never something we saturated on Solana anyway. We were maybe doing 30 or 40 TPS, I think, on Solana back in the day, and doing low single digits, I think, of Solana block space in terms of TPS, which was quite cool. But we could have always scaled it to more. It's just like a function of demand, and also like how quickly you update Oracle prices and other stuff, how often people quote. At the moment, we're seeing about 300 to 500 TPS, but we haven't honestly optimized a lot of the code in the sequencer. It can improve a lot. We actually, I don't know how much I can share on this, but we made some pretty big breakthroughs the last couple of days.
As much as you want, everything.
Yeah.
Just give us the source code.
Sure, but yeah, we started finally spending time on optimization, because we've basically gotten more or less feature complete, and we've got a lot of the reliability down pat. So a lot of it is just like speeding things up now. So we got from a few hundred TPS, we've now almost doubled that, essentially, just using some like pretty straightforward optimizations to the sequencer, thinking about how state is locked and stuff like that. So, reducing how we do disk access and a lot of these nerdy engineering things. So the more that we spend time on that, I think things will get faster. Our benchmark obviously is like what's happening in the DeFi perp space, which is Hyperliquid is doing sustained 5K TPS. So if we can get to that, I think that's a fair benchmark for us to get to. Solana is also doing 5K TPS. So that's just like, we got to get to that number, and that's kind of table stakes for us.
So I'm curious how you guys think about equality of access to data coming off the sequencer. So there's this kind of interesting thing with like Solana, where there's obviously a bias where the person who produces the block knows what's in the block faster than everyone else. But because distribution of blocks is like fairly broad across multiple validators, the highest validator's got like 5% of stake on it. You have this system where it's very hard for some to have a structural advantage because things keep moving. With a single sequencer, it's a little bit different because, first off, like obviously your sequencer knows what it's producing, but those folks who co-locate next to the sequencer have like a data asymmetry relationship relative to someone who locates a little bit further away. Plus, there's kind of this thing about, as much as we like think packets arrive at the same time, like they don't. And so on Solana, there's a turbine tree, which is stake weighted. And obviously everyone knows, like, if you are further up in that tree, you get data more quickly, and that's actually monetizable if you're a trading firm. So how do you guys think about that with a central sequencer where you don't have sort of some third proxy like stake weight to determine the order in which data gets sent out from the sequencer?
Yeah, it's a really good question. And I think the model definitely looks more like centralized exchange model. We kind of expect anyone who is a serious trader to co-locate. And I would say if you're a serious trader and you're not co-locating with Binance and you're trading on centralized exchange venues, you're just putting yourself at a huge disservice. Like, you can make your algorithm as fast as possible, but if you're running it halfway across the world, you're just paying 100 milliseconds in round trip latency. And that's just definitely not going to cut it. So I mean, it was definitely like, you're seeing a lot of dexes also do this. This kind of it's just like pretty well understood that most of these guys are running their algorithms out of, some of these data centers, I guess, in Tokyo and whatnot. And so I think it's expected that anyone's going to be market making is going to be running there. It's also nice because, if you are doing, for example, an arbitrage program, you basically have very fast connectivity between us and Binance, between us and Hyperliquid, all kind of within that same place. So yeah, I expect people to be doing that. I think that's a nice model and is going to work pretty well. So I wouldn't say we have prioritization there. Everyone still talks to the same sequencer. There should be fairly uniform data dissemination there. We're obviously going to have to add rate limits and make sure that people don't abuse it like they tend to do on traditional exchanges. There's all kinds of HFT, I wouldn't say exploits or shenanigans that people do to try and get first in the queue and stuff like that. So we're going to have to address a lot of these things. But yeah, it's pretty important that we give fair kind of, like auto priority to people, as well as data dissemination. I mean, it's all kind of done through WebSockets and stuff like that. So we should be able to give it out roughly to the same people. And I think, yeah, you kind of take out that element of complexity of having to distribute and send through this turbine tree across the world.
Yep.
Yeah, everything's kind of in the one place. I think there is a distinction as well if you're running a front end essentially, and I'm in Europe or something or other, and I'm trading these products. Typically, I don't think that extra 100 milliseconds or whatever will matter too much to your interaction speed. Like, you are not doing high frequency trading from
the minute you're clicking buttons, you're already behind the game.
Yeah, exactly. And I think it's really just like that kind of latency below 100 milliseconds is just really geared to the algorithmic traders. And I think anyone that's serious will be doing co-location.
Interesting. All right. Well, where can folks find out more about Bullet?
I think Twitter is the best place. So it should be bulletxyz_. I think it's the Twitter handle. I'm also on Twitter, Tristan0x. I just post a bunch of engineering updates and the latest and greatest. We should be having some exciting stuff coming up. We're going to be having a testnet trading comp. It's been a little bit delayed because we've been trying to just like improve stability and make sure that the trading experience is really good. But that should be coming out in the next couple of weeks, or probably by the time this episode airs. So that's a nice way to go in there, paper trade essentially without real money, play around and essentially try help us break the testnet as much as possible, find and resolve any issues. And we're going to put up some pretty meaty cash prizes. So, people actually trading there feel like they own something good. And I think that will give you a really good taster of what is to come without kind of risking too much on the line. And then I don't want to leak too much alpha, but we are pretty close to mainnet, which is nice. We sort of have, it's kind of been achieved internally almost. And we're just looking to like slowly roll that out. So we're going to do kind of like a gated rollout. So if people are like really serious traders, trade a bunch on existing exchanges, really live and breathe perps, we want to kind of get these people on, give them an early kind of preview. I think just focus on getting it out to a few hundred, just like really smart, capable people who can rip us with a bunch of feedback and help us improve the product. And then we'll kind of stage and gradually release it to a kind of wider audience. But yeah, devs have been very busy. A lot of stuff is shipping in the next couple of months. I think, things are kind of really taking off. And I think this whole CLOB wars and on-chain trading experience kind of space has really kind of heated up. And I think we'll continue to do so going into the end of the year at least.
Awesome. Well, Tristan, thank you for joining us today on Validated.
Likewise. Thanks for having me on. Great questions.
Thanks.